For the past few years, let's be honest, the story of AI has been this incredible, almost unbelievable explosion of progress. Models got bigger, benchmarks were shattered, and things that once felt like pure science fiction are now everyday tools. But what happens when that playbook, the one that got us here, just stops working? The game is changing in a big way. We're at AI's halftime. For years, the rule was simple. To make a model smarter, make it bigger. More data, more parameters, more computing power. But that playbook is failing. We've hit a wall of diminishing returns where a tiny improvement costs a fortune. And worse, the fuel for that old engine is running out. Projections suggest that by as early as 2026, we could exhaust the supply of high-quality human-generated data for training. This creates a strategic vacuum and forces us to answer the most important question in the field. If the old way is dead, what's the new way? The answer is a fundamental shift in focus, a shift from brute force learning to elegant reasoning. When you can no longer rely on endlessly ingesting more information, you are forced to get smarter with the information you already have. It means the future of AI isn't about building a bigger library. It's about building a vastly more intelligent librarian. This new type of AI won't just be a know-it-all. It will be a discovery engine, a reasoning partner designed to dramatically accelerate human innovation. Think about what that actually means. In medicine, an AI could cross-reference the entire library of genomic research with every clinical trial paper ever published. It could find a hidden link between a gene for one disease and a drug used for another, generating a brand new, testable hypothesis for a human scientist. This allows the human to start from the absolute cutting edge and focus their effort on creating something genuinely new. That is the future. Not just an AI that knows things, but an AI that helps us discover things we never knew were connected. It's an entirely new goal. We must shift from building AIs that are simply learning machines to building reasoning engines. What does that actually mean? It means moving beyond just knowing facts. Reasoning is the ability to synthesize, to find the hidden connections between pieces of information you already have, and from those connections, generate a brand new insight that didn't exist before. But this raises two most important questions. One, what kind of system do you need to build to actually enable that kind of reasoning? And two, why reasoning did not work as efficiently so far, but can work better now? To answer those questions, we can look at the engineering of the human brain. The brain didn't solve the problem of intelligence by brute force. It doesn't just store facts in a giant pile, it organizes them in a way that is built for connection and discovery. At its core, it uses a sophisticated architecture known as the key value system. The real genius is the retrieval system. In this system, every memory is split into two parts. The value is the book itself, the rich, detailed content of the memory, but the key is the index card. This biological blueprint is mapped directly onto the brain's anatomy. The huge, wrinkly outer layer of the brain, the neurocortex, is the library. It's the massive hard drive storing all the high-fidelity values, the sights, sounds, and emotions of your memories. Deep inside, the hippocampus is the master librarian. It doesn't store the memories themselves, it specializes in creating unique, distinct keys for every experience. When you want to recall something, the hippocampus provides the right key, which instantly unlocks the exact memory pattern in the vast neurocortex. This system is incredibly smart. For example, the brain ensures those keys are unique with a trick called pattern separation. If you need to remember where you parked today versus yesterday, your hippocampus makes the keys for those two memories different enough so you won't confuse them. It's a dynamic, self-organizing system built for precision. This elegant, time-tested architecture is the exact blueprint researchers are now using to build the next generation of AI. And they're applying that blueprint to solve a problem that perfectly illustrates the difference between biology's elegant design and digital brute force. Our most cutting-edge AIs struggle with the exact same memory problem our brains solved ages ago. In AI, this is called catastrophic forgetting. One method is experience replay, which is essentially digital rehearsal. The AI stores past data and periodically replays it to reinforce old knowledge. Another is elastic weight consolidation, a clever protection mechanism. It identifies the most critical connections for an old skill and anchors them, protecting them from being overwritten by new learning. Both of these are strategies to protect the keys to old knowledge. To test this, researchers mimicked forgetting in AI. They trained it on one task, recognizing handwritten numbers, and it performed perfectly. Then they trained it on a second, different task. When tested again on the first, its performance collapsed to just 9%. But here's the crucial part. The original data wasn't deleted. It was still inside the network, just inaccessible. Researchers then artificially boosted the signal of the old keys tied to that first task. The result was astonishing. Without any new training, performance shot back up to 99%. This biological blueprint isn't just theory anymore. Researchers are now building AI architectures directly on these principles. Enter Hippo RAG. It's an AI memory system explicitly designed to copy the key value architecture of the brain. The neurocortex is the large language model, but the breakthrough is its hippocampus-like component, a structured knowledge graph. The results are stunning. Complex questions answered up to 13 times faster and at 30 times lower cost. It's not brute force, it's intelligent design.
So where does this leave us? We stand at a turning point. The era of building bigger, brute force AI is ending, and the era of intelligent design inspired by the elegant architecture of the human brain is just beginning. This journey isn't just about building a better memory system in a machine. It's about upgrading AI's fundamental role in our world, from a simple learning machine to a genuine reasoning partner. This new kind of AI, this reasoning partner, is designed for that real world. It's not about scoring high on an isolated test. It's about helping us discover new solutions, just like in the examples of medicine and engineering. We're finally building AI to tackle the right problems. We're not just creating better search engines to find old facts. We are building the world's first true discovery engines, AI collaborators that can synthesize all of human knowledge to help us cure diseases, design sustainable materials, and tackle problems we once thought were unsolvable. The question is no longer whether AI will get smarter. The new, more exciting question is how human intelligence will evolve alongside it. We are building more than just a tool. We are building a cognitive partner for our entire species.